Picture yourself on a quiet night, away from the noise of cities. The stars shimmer gently overhead. Suddenly, one of those tiny specks grows brighter, brighter, until it outshines everything else in the heavens. For weeks, the sky is transformed, lit by a cosmic fire so powerful you can see it in daylight. You've just witnessed the death of a star, a supernova. But this is not just destruction, it's rebirth. Out of the ashes come the very elements of life: iron in your blood, gold in your ring, oxygen in your lungs. The universe dies so it can live again. Tonight, we'll uncover the mysterious story of supernovas, the grand finales of stars, the forges of creation, and the cosmic whispers that tie you to the stars themselves. A life of a star. Stars are not eternal. They are born, they live, and they die. They begin in dark clouds of gas and dust, stellar nurseries. Gravity pulls matter inward, tighter and tighter, until nuclear fire ignites. The star is born, a new sun among billions. Small stars like our sun burn steadily, lasting billions of years. But the giants, they live recklessly. They shine thousands of times brighter, but burn through their fuel millions of times faster. They live not for billions, but millions of years, a brief flicker in cosmic time. And when their fuel runs out, their peaceful glow turns into a violent countdown to death. What is a supernova? A supernova is the most dramatic ending in the universe. When the fuel is gone, gravity, the very force that built the star, betrays it. The core collapses in seconds. Atoms are crushed. The outer layers slam inward, rebound, and explode outward with unimaginable force. For a short time, that single dying star shines brighter than an entire galaxy. Billions of stars dim in comparison. If one happened in our galaxy tonight, you'd see it with your naked eye. It would be impossible to ignore. The two faces of doom. Supernovas come in two forms. Type 1, the star thief. This happens when two stars orbit each other. One begins stealing material from the other, like a thief in the night. It grows, becomes unstable, and finally, it detonates. Type 2, the giants fall. This is the fate of massive lone stars, at least 8 times the size of our sun. They burn furiously, then collapse, then explode in a violent outburst that scatters their remains across the cosmos. Both unleash energy beyond anything humans can imagine. More than our sun will produce in 10 billion years, unleashed in mere seconds. The aftermath. The death of a star should mean silence, but instead, it leaves behind some of the most bizarre objects in the universe. Neutron stars, the collapsed core of a star, packed so tightly that a spoonful of it would weigh billions of tons. Some spin at incredible speeds, flashing beams of radiation across the universe. Cosmic lighthouses called pulsars. Black holes. If the collapse goes further, gravity wins completely. Not even light can escape. A black hole is born, a region where time and space themselves are twisted beyond recognition. And then there are the remnants, the colorful, expanding clouds of gas and dust thrown into space. They glow in eerie blues, reds, and purples, forming shapes like spider webs or ghosts. They are beautiful, haunting, and alive with potential. Because these remnants are where new stars are born. Out of death, life, Stardust and us. Here's where it becomes personal. Every atom in your body heavier than hydrogen was forged in a star. The iron in your blood, the calcium in your bones, the oxygen in your lungs, the gold on your hand, all of it was created in supernovas. You are not just made of stardust. You are stardust. It's not poetry, it's fact. You are the ashes of stars, walking, breathing, thinking. And when you die, those atoms return to the earth and eventually to the stars again. It is the greatest recycling program in the universe. Ancient witnesses. Humans have watched the heavens for millennia, and they have seen stars die. In 1054, Chinese and Japanese astronomers recorded a guest star so bright it was visible in daylight. Native American tribes painted its memory on canyon walls. Today, we call it the Crab Nebula. In 1604, Kepler watched a brilliant supernova blaze in our own Milky Way. He wrote that it was as though heaven itself had changed. And in 1987, astronomers in Chile saw a star explode in a nearby galaxy. For the first time, we had the tools to study it in detail. That single event still shapes our science today. Imagine the awe, the fear, the wonder ancient people must have felt, watching a star die, not knowing what it meant. The next one. Here's the chilling part. We are due for another. One candidate is Betelgeuse, the red giant in Orion. It's so massive, so unstable, that it could explode at any moment. Tonight, tomorrow, or 100,000 years from now. When it does, it will be visible even in daylight. The night sky will be forever changed. Humanity will witness something not seen in centuries. The death of a star in real time. Imagine walking outside, and where Orion's shoulder once was, you see a new light, brighter than the moon, blazing in silence. It could happen in your lifetime. The dangers of supernovas. But supernovas aren't just beautiful, they're dangerous. If one happened too close to Earth, the blast of radiation could strip away our atmosphere. Entire ecosystems could collapse. Some scientists even believe mass extinctions in Earth's history may have been triggered by nearby supernovas. Luckily, the stars closest to us are stable. But the thought remains, the universe is not a safe place. It is violent, unpredictable, and constantly reshaping itself. Mysteries yet unsolved. And even with all we know, mysteries remain. Why do some stars become neutron stars while others collapse into black holes? What truly happens inside the heart of the explosion, where no light escapes? Could a nearby supernova one day change the course of life on Earth? And the biggest mystery, if black holes are born from these explosions, could they be gateways, bridges to other universes, portals to the unknown? Science doesn't know, and maybe we're not meant to, yet. The bigger picture, supernovas remind us that destruction and creation are inseparable. Stars die so that new stars, new planets, and new life can exist. The universe builds itself by tearing itself apart. It is a cycle without end. And you are living proof. A fragment of stars, thinking, breathing, asking questions about the cosmos that created you. So, will we see the next great supernova in our lifetime? And if we do, what will it make us feel? When you look up at that blinding light, remember, you are not just watching a star die. You are watching the universe write its next chapter. You are Stardust, watching Stardust. And in our next journey, we'll go even deeper into the Great Attractor, a mysterious force pulling our galaxy across the universe.